Oggi parlo della risorsa, and that's all I can say in Italian. So I'm switching to English now. So usually when we think about our applications, we think about them in terms of a script. A script like when playing theater. A script that tells us line by line what to do. So it's mostly about the control flow. And this metaphor is not wrong. However, when we switch over to the signal-based world, to signals and resources and so on, then we need to switch our thinking. Then we need to think about our application more of a marble run, where several marbles go through. And those marbles represent our data items going through the application. And sometimes such a marble can be transformed. For instance, when it goes in here into the hall, then it might be transformed. Sometimes a marble might even be split into several marbles, and sometimes several marbles might be joined to one marble. And at the end of this data flow, we have some marbles that are usually displayed to the user by means of data binding. Usually we use data binding. Sometimes data binding is not possible because we need to call a method in order to display a toast message or something like this, but usually in Angular the data binding is the way to go. That means when switching over to signals, when switching over to reactive programming, we need to have a more data flow centric perspective on the whole application. And this is what this whole talk is about. I want to show you how to go with this data-centric perspective together with signals. For this, I've prepared some points for you. I will get started with an invisible concept that is really important here, the signal graph, which shows you how the data flows occur in your application. And I will combine it with the newest version of the resource, namely the http resource. For this I have a demonstration. Then we will go on, we will investigate the signal graph in my demonstration, and then we will have another look on it where I will tell you in detail how the http resource is working. Before we start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I'm helping a lot of companies with Angular. I and my team do a lot of trainings there, consulting and reviews. And besides this, I'm also quite connected to the Angular community. I live in Austria, I do a lot of stuff in Germany, and I'm always happy to work together with people around the globe, on-site or remotely. Okay, cool. So let's get started with the signal graph. So the signal graph is more or less invisible currently. In the future, there might be some debugging tools to visualize them. However, indirectly, you can see it in your code. So here I just have a little tiny example for this. Here I have an original name and an English name signal. This is out of another example I've done, I think, last year here on NG Rome, which is about searching for deserts. A very important topic, deserts. And here I could have searched with the original name or the English translation. In my case, the original name is a red marble in my marble run, and the English name is a dark red marble in this marble run. What I have here is a resource, an HTTP resource, and you already see my red and dark red marble goes into this HTTP resource. Every time we have a new value there, the new value goes in and triggers something in there, triggers some data loading in there, and what comes out is the value of this data loading, which is my loaded deserts array. Then I also have loaded some ratings of my deserts, and one more time, both marbles, the blue marble and the purple marble, go into a computed, And in the computer, those two marbles are joined to my rated desert marbles. That means two marbles go in, one marble is coming out, and this is the marble we will display to the user, usually via data binding. So more or less you can see this important signal graph here and this important data flow that goes through our application. Of course, this is a lot of theory, and that's why I have prepared a demonstration. It was a flashback to my childhood. Okay, yeah, so you see, sometimes it's really about the simple topics that make us fail. So, as mentioned before, a flashback to my childhood, Super Mario. I have implemented this with Angular, and one of the nice things here is we can scroll through the levels, and I almost can hear the sound. Can you hear it? Like da 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 da. And we can also switch between the levels. So here, for instance, I have level 2. Okay, so at least this was the idea. Perhaps I have destroyed something. I don't have much luck today. Perhaps we should start the application. Can help, people told me. Level 2, yeah, here we have level 2. And perhaps you did not know it, in Super Mario you have 4 themes. And usually each and every theme is connected to a level. But in my implementation I can completely switch the themes. For instance, I can switch between overworld, underground, underwater, and castle, and so on. What we have here is the percentage of all the items I need to load. So here I have already loaded 100%, so everything seems to be fine, and I can use my application. So the funny thing about all of this is, for implementing this, I'm using a tiles map, a good old tiles map. I have borrowed this tiles map from the internet, and if we scroll into this tiles map, we see something that is very funny. We see that we have those 4 themes, and all it takes to jump from one theme to another theme is to calculating an offset. A horizontal offset to get from overworld to underground, or a vertical offset to get from underground to underwater. And this is what I'm basically doing in there. But there is more to this. I have here a level overview file that tells me which levels I have. And besides this, I have a level description. So far, I don't have a level editor, but this might be the next stage to implement a nice editor. Currently, I just have to implement my JSON files. And those JSON files tell me where which tile has to be presented. For instance, the floor tile starts at column 0 and row 13, and then it is repeated 55 times from the left to the right. So if we double check this, level 1, stop animation. Here I have column 0, this is the row 13, and then from left to right it's repeated 55 times. Yeah, so you can imagine I had a lot of fun when implementing this example. Okay, cool. So now let's think about the signal graph of this application. When we think about the signal graph of this application, first of all, we see several signals. Signals, for instance, for all my parameters, like the style, which is the theming I have activated, the animation toggle is the animation on or off, and the level key. Do I want to display the first level or the second level or any other level you might have implemented using my JSON format. Then I have a canvas, which is a view child, and meanwhile we can create our view childs with signals or get them via signals. On this canvas I'm painting my level. And then I also have here my tiles map progress, telling me if I have loaded 100% of the tiles map or a bit less. Besides this, I also have resources. I have this label resource that is loading my label description, this JSON format you have seen before. Every time I'm changing the label key, the right description for the respective label is loaded. Then I have my tiles map resource, which is loading the whole tiles map, which is a blob. So that means you can also load binary data with resources. And then I have my tiles resource. What is the tiles resource doing? Well, this is funny. It takes the whole tiles map. It takes the style, like overworld or underground, and then it extracts the right tiles from the tiles map by calculating the offset. And all of this now is going into an effect, into my rendering effect. Usually, you don't use effects for displaying data. As mentioned before, usually you use data binding. However, in this very example, the effect is the right way to go. Because I cannot paint on a canvas using data binding, I need some method that is called, and this is where the effect comes in. Perhaps this is one of the little very good solutions where an effect is appropriate. Yeah, and this will then paint on a canvas, and as some kind of entry truck, I have also my label overview resource to quickly get started with a very simple example. Okay, this is my reactive graph, and now let's have a look to the implementation of all of this. Okay, so let me double check something. No, so it seems like this is the way to go. Okay, so let's have a look at the implementation of all of this. What I have here is the label loader, and as in each and every horror movie, I'm starting quite easy, and then it's becoming more and more complicated. But first of all, let's have a look here. Here I have my function that is creating a resource for the label overview file. You see it here, I have httpResource, this helper function, and I want to load a label overview file, and for this I'm just pointing to the file name, to the URL. One thing that is important, and in 2 minutes you will see why it's important, you have to provide here the parameter via a lambda expression. One of the best additions here is the default value, because without a default value we would start with undefined. Obviously, it takes some milliseconds until my resource is loaded. And in those milliseconds, I would get undefined. And we all know working with undefined is not that funny. You always need this special if, and if you forget about it, the compiler yells at you or you have an issue at runtime. That's why usually I have now dummy objects for all of my resources. If you did state management in the past, you know this game, you know that everything is better than undefined. Also here, object with an empty array. Okay, so now let's have a look at getLabelResource. Here I'm doing more or less the same. I have here my HTTP resource of label, and here I have my lambda expression that is returning my URL. And now we see why all this data needs to be presented as a lambda expression. Because in here we could use a signal, like my label key. And every time this signal is changing, the resource is triggered again. The resource will start loading the new URL. But you see something else in here. Sometimes we don't want to trigger the resource. Sometimes we don't want the resource to load something. And for those cases, we just need to return undefined. So in my case, when we don't have a label key, I'm just returning undefined, and so the resource will do nothing. One more time, here I have my default value, and I can provide a pass function, which is just a function that is taking the raw value from the server, the raw value, and then it can revive the raw value. Perhaps you know JSON.bars. Who knows JSON.bars? Of course, everyone. Who knows the reviver parameter? It's the second parameter of JSON.bars. So this reviver is also just a function that allows you to revive your application in terms of, for instance, exchanging date strings by real date objects, or by exchanging other properties by more richful properties. And this is what you can do here. So basically, the parser is reviving your values like dates, and it can also check whether the data structure from the server is in the right format. If you don't trust your server colleagues, then this might be a good way to enforce that you get the right format. Originally, bars was called map, but map was a bit misleading, and I also did the mistake of thinking it's about general purpose mapping. No, it's mainly about mapping in the sense of reviving and in the sense of checking the data format. Usually, you don't use a handcrafted function here, but some schema library like that. So what do we have else? Here we have another function loading a resource, and this is more or less an alternative for loading a level, but here you see more options. Instead of just returning an URL, I'm returning a whole object with a lot of data, like the URL, of course, or some headers I want to send over, or some parameters. And one more time, when one of those signals is changing, we are triggering the resource again. You can also switch from get to other methods, like post or put. Usually, I don't talk much about it. Usually, I pretend this does not exist. So for me, this is like Star Trek 11. For me, it does not exist because it was really a bad movie. But honestly, sometimes you need methods beyond get, because you cannot control what you have on the server side. Sometimes there might be a method that needs to be called via a post call. Perhaps because you have that many parameters you want to send over in the payload, or perhaps you have a SOAP service where everything is post. However, this should not tell you that you can mutate data, because the resource API is not about updating data, not at all. It's not intended for this case. One reason for this is it has switch map semantic baked into it. And usually you don't want to go with switch map semantics when updating data. So resource is just for loading data, even though you can switch over to post, even though you can define a payload, a body. And also here you see typically properties you might know from the HTTP client, like report progress, tell us how much we have loaded from this resource, from our tiles map, for instance, transfer cache, and with credentials. Having similar possibilities than in the HTTP client is not a coincidence. This resource is using the HTTP client underneath the covers. That's why you have to provide the HTTP client when using the resource. At least this is the current implementation. It's an implementation detail that might change over time. We will see. Okay, here I have my tiles map loader. And here you see how to load binary data. I just load a blob here. There is another method for loading plain text or an array buffer. I really like this way of doing things because I have now this secondary function, as I call it, a method within the HTTP resource function that tells us, hey, now we want to go binary. Okay, cool. So now let's go to our level component. In there, I have another function that is creating another resource. This is now a traditional resource. This is now a resource that is triggered every time when something is changing. And every time something is changing, an asynchronous operation is called. So what needs to change to trigger this resource? Well, this is here defined by this computed. When the tiles map is changing or when the style is changing, I want to re-trigger this resource. And one more time, if I don't have a tiles map because it's not loaded, I just return undefined, which will not trigger the resource at all. So this is in general the trick here. If we don't want to do it anything, just return undefined. This is my resource. My parameters is this computed signal. And when it returns something other than undefined, the loader will be triggered. And here you see the loader is just delegating to my extract tiles function. It's here a black box for us of my game engine extracting all the tiles. Okay, so when looking back here to this graph, as mentioned before, we have all those signals for my properties. We have the canvas, we have the tiles map progress, we have the label resource, the tiles map resource, and the tiles resource extracting the right tiles. So now let's see how this looks like in our source code. In our source code, we have the same. We have the canvas, which is now a view child we get as a signal. We have the label key. We have the style and the animation signal. And here it's becoming interesting where everything is interconnected via resources. Here we see that we get the tiles map resource from the tiles map loader, the label resource. Every time the label key is changing, it's loading a new label. We get the label overview, and we get the tiles map resource that is extracting the tiles for a given style from our tiles map. Also, for the tiles map resource, I'm grabbing the progress signal telling us whether we have loaded 10%, 20%, 100% of the tiles map. And here we have something you usually don't see in a good Angular application, an effect. As mentioned before, as we need to call a function to paint something on the canvas, we need it here. And what this render function inside of the effect is doing, it is first of all reading all the values we need. And that means the effect will trigger, no, will not trigger, will track those signals. Every time one of those signals is changing, the effect will rerun. And basically the effect is just delegating to the black box, to my game engine here, to animate a level or to just render the level if the animation flag is not on. This is where all the theory comes together. Okay, nice. So let me conclude. What did we see today? Well, we have seen when we work with signals with the resource API in a reactive way, we are building a reactive graph. You have to read between the lines to see the reactive graph, but perhaps in the future we will have some ways of visualizing it in debug tools. We have this new HTTP resource that is really powerful. It allows us to fetch data directly within this graph, within this whole marble run. And you have seen it before, I don't directly create my resources in my component. I have helper functions, methods that are doing this. Usually, I put the creation of an HTTP resource in my data access service. And last but not least, please don't forget about this. Think about your application in terms of a marble run. And that's it. I have already uploaded my materials, my application, and my slides to my blog. You can find it here. And follow me on social media to stay in contact. Thank you.